Hi everyone, in this video I will show you how to debug your model that you wrote, your documentation using Visual Studio Code. Sometimes we want to check our model using the GUI, something more high level to say that everything is working, and sometimes we see a problem and we want to understand where is our problem, and we just want to have breakpoints and to check this code and to see that everything is working properly. Sometimes the model can be complicated of what we wrote, and this is why we have this the option to debug our model. Okay, so open Postman. Now my server is down, so nothing will work. Okay, I'm clicking. 1 second. Oh, my server is up. Okay, so if my server is down and I'm clicking on request, then nothing will work. Okay, so the first step is to run our server. Okay, so I'm running it, and now all of the requests will work. And what we want to do is we want to debug our model. So in here, in the PHP directories, I have the path to where my documentation is, and it's supposed to be, as all the times in this tutorial, we are working on the same example: AOS, experiments, tutorial, the paper example. Okay, so make sure this path is correct. And in here, now we have a slight difference. We are putting this field only generate code to be true. We don't want to run the AOS automatically. We want to debug it. So this is important. Is internal simulation also true, because we don't want to run the robot. And so these fields, they are not so important. They are connected to ROS when we are activating the robot. In here you can state the number of particles, how much particles we want to approximate our belief state. And the manual control, this is important if you want to debug special actions, and in this case we do want to debug the actions we select. If we will say false, then the AOS will autonomously run a simulation internally without operating the robot. When we are saying true, then the AOS ignores the search operation in the AI algorithms, and we are selecting which action to operate in every time. So this is true. Okay, so I just want you to understand the difference. Is internal simulation is telling us if we are activating the robot or doing the simulation internally, and manual control is telling us if we are using AI, or if we are sending every time the action we want to execute. Okay, so now let's send it. And what it did is now it's generated the code based on this documentation inside our AOS solver. Now let's start Visual Studio Code. And debug our project. So the first thing is we want to open the folder where our solver is, AOS solver. Open. Let's build it. So the first thing we want to do is to see that everything is compiled correctly, and if I will have a typo or something inside my document, then it's compiled. I will show you this after it ends. Okay, so now we see everything was compiled correctly, and if I will now enter some typo here, okay, and send the request again, okay, and now we'll click on build in the lower panel, or you can also say write like this, cmake build. Okay, you will see that we will have an error. Okay, so here is our typo. We can click Control and go directly to see it, and you see here state.robotlocation.y equals y, and here is our typo. And okay, so this typo was from here. You see state.robotlocation.y equals y. Okay, so we can remove it from here. You can also, if you have a lot of errors, you can just remove it from here and to do a build again, and then to reduce your errors until everything is working properly, and then to correct your documentation. Okay, so what I will do now, I will just send the request again after I corrected the documentation, and build it again, and everything will work properly. Cmake build. Okay, see 100%. Okay, this is probably an old version of the same file. Now, let's look at this solution, the AOS solver. What are the important files? Most of it's not important for us. What is important is in here we have the examples directory, and this is the model. In our case, CPP models and example. Example is the name of our project. Okay, just to show you, if I will write in here example 2, and all of the documentation file, it's supposed to be the same. Example 2, and send it again. Okay, you see example 2. It generated. It's generating the our model inside this directory, and in here we can see the name of our project. In here, this file, it contains all of our model. Now, if I want to debug my initial belief, okay, in here we see here the initial belief, okay, and I want to debug it. I want to debug this line of code to see that every time I'm generating valid initial states. So what I'm doing here, I'm going to this file, okay, our model file, and I'm searching create start state. Okay, this function, it runs our initial state, and we can find in here the exact code we wrote. We can see in here state robot action discrete Bernoulli 0.5. okay, and this is the code we see here. Okay, and we can place a breakpoint and debug it. What it's doing in the beginning, it's running multiple times this code that creates new states. It generates the initial belief, so it's generating in the beginning, in this case 20,000 states to approximate the initial belief. So we have a lot of opportunities to debug this location, and every time we can sample a different it will sample different initial states, and we can see that our code is working properly. Okay, so in here, okay, -1, and then we can click F10 to go to the next line, and it's sample location 3. Okay, and we can run to the next state and check it again. 3. Okay, let's place the breakpoint here, and we can also add a watch. I'm copying this and adding a watch on this variable, and let's look at it. 3, 1. Okay, so it can sample. I'm seeing that it's sampling different states. Very nice. Let's see when it will take 2. Okay, it's taking 2, so it looks good. Okay, so this is how to debug our initial belief. This function creates start state. Now, if we want to debug our skill documentation, in this case we have a single skill called navigate, and we want to debug it. So we can go in here in the same file to the step function. Okay, so I'm going here to the step function, and in here we have the function to check the preconditions. If we define preconditions here, okay, so the preconditions, they will be checked here, and in here we can have extrinsic changes which are defined in the environment file in the extrinsic changes. It's extrinsic code here, and we have the dynamic model. You can go to definition, and here we will see the dynamic model for the navigate action. Okay, and you can simply debug it when we will perform the navigation, and this is the code we are seeing here. Okay, now, okay, so now I want to debug the navigation. I will remove this breakpoint and run the process. Okay, and now because we said it's manual activation, okay, in here manual control true, now it's waiting for us to send an action manually. Okay, so we have this request, and I'm reminding you the whole collection, this collection, it's inside the tutorial. You can import it. It's inside this tutorial. You just import the collection from this file, click import, and then import this file, and you will have all of these requests. And in here we can click the get solver actions, send, and now we will get all of the possible actions. Okay, action ID 2, it will do this thing. Action ID 1, action ID 0. Okay, and we are seeing the description, which parameters are sent for this action and everything, but we want to perform this action. Okay, action ID 0. So we are going to the send action manually and just changing it to 0 and sending it. Okay, so and here it's going straight away to the breakpoint, and we can debug it. We can see that the action 0, the discrete destination is 1, and it looks good because if we will go to the get solver action, we are seeing that the parameter of discrete destination is 1, and in here we can debug our code that the logic we wrote is okay. So that's it for debugging our dynamic model. And one last thing, sometimes we want to debug our special states. Okay, in here in the environment file we can describe special states that they are giving certain rewards, and sometimes it's goal states, and sometimes we have a one-time reward, like in this case that after it was given one time, we want to stop evaluating it. So the place where this calculation goes, it's in process special states, and it's also inside the step. Okay, inside the step function, it's performing these steps. Okay, it's checking the precondition, the extrinsic changes, then the dynamic model, and then it checks if we have special states like terminal states. Okay, so that's it. I hope it was clear. Thank you.